Okay, thermal efficiency. So this is the cycle of the steam of the heat engine. Just now, you are receiving heat, right? You are receiving heat at higher temperature, okay, producing work, and rejecting waste to the lower temperature reservoir at TL. So this is Q out. You are losing Q and QL, we put it as QL. This is high temperature, QH. Okay, this is TH, this is TL. So this is schematic diagram of heat engine. We will be using this a lot. Okay, so thermal efficiency. How do you know how do you know the performance of the heat engine? Is it good, okay, or not? So we are using this equation. We need to identify the thermal efficiency. Okay, thermal efficiency equals to desired output over required input. Okay, which one is input, which one is output? Okay, equals to net work output over total heat input. Okay, or it can be represented by this equation. Okay, so equals to work net out, net work output over total heat input. Heat input is Q in. Okay, network output is desired output, required input is total heat input. Okay, Q in being supplied is actually the QH. So work net out over the QH, and you know that work net out is actually equal to Q in minus Q out. So you can replace this, okay, Q in minus Q out or QH minus QL, and you can replace this, okay, by this. Okay, so can we save Q out? No. Why? Okay, so remember the characteristic. Just remember the characteristic of heat engine. We need to reject. We need to have the losing some heat in order to make sure that the heat engine in still in operations, and we need to keep the cycle goes on. Okay, so every heat engine must waste sink some energy by transferring it to a low temperature reservoir in order to complete the cycle, even under idealized condition, or else we go for Kelvin. Okay, so this is a Kelvin-Planck statement. Okay, this is Kelvin-Planck statement. Okay.